When using service entrance or C cable, bonding the electrical panel to the meter socket is still required. This is in accordance with the National Electrical Code, specifically sections 250.102, C in 250.64. Each section 250.102. C states that metal enclosures for service equipment shall be bonded to the grounding electrode system. Similarly, section 250.64. E mandates that metallic conduit, raceway, cable armor, or other metal enclosures containing service conductors shall be bonded to the grounded conductor at the service. SE cable is a type of service entrance cable. Typically, it consists of 2 or 3 insulated conductors, which serve as the hot wires. It also includes one bare or insulated neutral conductor and one bare ground conductor. The bare ground conductor within the SE cable serves a very important purpose. It is designed to establish the bonding connection between the electrical panel and the meter socket. Now, let's discuss the specific method for bonding the panel to the meter socket using SE cable. Firstly, carefully remove the outer jacket of the SE cable at the meter socket location, taking care not to damage the inner conductors. Secondly, expose the bare ground conductor. Wrap this exposed bare ground conductor securely around the bonding screw provided in the meter socket. Thirdly, tighten the bonding screw firmly to ensure a solid and reliable electrical connection. Finally, run the SE cable from the meter socket to the electrical panel. Inside the panel, connect the ground conductor to the designated grounding bar. By meticulously following these steps, you will have successfully established a proper electrical bond between the electrical panel and the meter socket. This bond is absolutely essential for maintaining electrical safety and ensuring effective grounding of the electrical system. Let's delve a little deeper into each of these steps to clarify the process. When removing the outer jacket of the SE cable, use a utility knife or cable stripper with caution. Avoid cutting too deeply, as you could damage the insulation of the inner conductors, which would compromise the safety of the installation. Expose enough of the bare ground conductor to allow for a secure wrap around the bonding screw. The length of exposed conductor will depend on the design of the meter socket. Consult the meter socket's instructions for the manufacturer's recommendation, if available. When wrapping the bare ground conductor around the bonding screw, make sure the conductor is in direct contact with the metal of the meter socket enclosure. Any dirt, corrosion, or other foreign material can impede the electrical connection. Clean the conductor and the bonding surface, if necessary, to ensure good contact. Tighten the bonding screw securely using a screwdriver or wrench of the appropriate size. The screw should be tight enough to provide a firm mechanical connection, but not so tight that it strips the threads or damages the conductor. Refer to the meter socket's instructions for any torque specifications. When running the SE cable from the meter socket to the electrical panel, follow all applicable codes and regulations. Support the cable properly to prevent strain on the connections. Use cable clamps or other approved methods to secure the cable to the building structure. Inside the electrical panel, connect the ground conductor to the grounding bar. The grounding bar is typically a metal bar with a series of screws or lugs for attaching ground conductors. Make sure the ground conductor is securely fastened to the grounding bar. Also, confirm that the grounding bar is properly bonded to the panel enclosure. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. Adhering to these requirements is crucial for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker and energizes the circuit. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, which minimizes the risk of shock. Understanding the difference between grounding and bonding is essential for safe and effective electrical installations. Grounding connects the electrical system to the earth. Bonding connects metal parts of the electrical system together. Both grounding and bonding are necessary to provide a safe electrical system. When working with electricity, always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. De-energize circuits before working on them. Verify that the circuit is de-energized using a voltage tester. If you are not comfortable working with electricity, hire a qualified electrician. Electricity is dangerous, and improper electrical work can result in serious injury or death. Let's elaborate further on the NEC requirements. Section 250.102 C, mentioned earlier, emphasizes the bonding of metal enclosures for service equipment to the grounding electrode system. This grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode. The purpose of this requirement is to provide a low impedance path for fault current to flow back to the source. By bonding the metal enclosures of service equipment to the grounding electrode system, any fault current will quickly trip the circuit breaker or fuse, thereby minimizing the risk of electrical shock. Section 250.64 E focuses on bonding metallic conduit, raceways, cable armor, and other metal enclosures that contain service conductors to the grounded conductor at the service. The grounded conductor is typically the neutral conductor. This requirement ensures that all metal parts of the electrical system are at the same electrical potential. If a fault occurs, any metal parts that are not properly bonded could become energized, posing a shock hazard. By bonding all metal parts together, the voltage difference between them is minimized, reducing the risk of shock. In addition to the NEC requirements, local codes and regulations may also apply. Consult with your local electrical inspector to ensure that your electrical installation complies with all applicable requirements. It is also important to follow the manufacturer's instructions for all electrical equipment. The manufacturer's instructions will provide specific details on how to install and operate the equipment safely. Ignoring the manufacturer's instructions can lead to equipment damage, electrical shock, or fire. Let's consider a practical example. Suppose you are installing a new electrical panel in a residential building. The service entrance cable is SE cable. To properly bond the panel to the meter socket, you would first remove the outer jacket of the SE cable at the meter socket. You would then wrap the exposed bare ground conductor around the bonding screw on the meter socket. Next, you would tighten the bonding screw securely. Finally, you would run the SE cable to the electrical panel and connect the ground conductor to the grounding bar inside the panel. By following these steps, you would have established a proper electrical bond between the panel and the meter socket. This bond would ensure that any fault current would quickly trip the circuit breaker, protecting you from electrical shock. It is important to note that the size of the ground conductor must be appropriate for the size of the service entrance conductors. The National Electrical Code provides tables that specify the minimum size of the ground conductor based on the size of the service entrance conductors. Using a ground conductor that is too small can compromise the effectiveness of the grounding system. In addition to the ground conductor, the grounding electrode conductor must also be sized appropriately. The grounding electrode conductor connects the grounding electrode to the grounding bar in the electrical panel. The size of the grounding electrode conductor is also specified in the National Electrical Code. When installing a grounding electrode, follow the manufacturer's instructions. The grounding electrode should be installed in accordance with the National Electrical Code. The grounding electrode should be buried deep enough to ensure that it is in contact with the earth. The grounding electrode should also be located away from any underground utilities. Let's discuss some common mistakes that people make when bonding electrical panels to meter sockets using SE cable. One common mistake is to not tighten the bonding screw securely. If the bonding screw is not tight, the electrical connection will be poor, and the grounding system will not be effective. Another common mistake is to use a ground conductor that is too small. If the ground conductor is too small, it will not be able to carry enough fault current to trip the circuit breaker. A third common mistake is to not properly bond the grounding bar to the panel enclosure. If the grounding bar is not properly bonded to the panel enclosure will not be properly grounded. A fourth common mistake is failing to remove paint or corrosion from the bonding surfaces. Paint and corrosion can interfere with the electrical connection and reduce the effectiveness of the grounding system. A fifth common mistake is using the neutral conductor as a ground. The neutral conductor should never be used as a ground. The neutral conductor is intended to carry the return current from the electrical loads. Using the neutral conductor as a ground can create a dangerous situation. To summarize, bonding electrical panels to meter sockets using a seat cable is a critical safety practice. It is essential to follow the National Electrical Code and local codes and regulations. It is also important to follow the manufacturer's instructions for all electrical equipment. By following these guidelines, you can ensure that your electrical installation is safe and effective. Now consider some additional factors that may influence the bonding process. The type of meter socket can affect the method of bonding. Some meter sockets have a dedicated bonding lug or screw, while others may require the use of a bonding jumper. The material of the meter socket enclosure can also affect the bonding process. Metal meter socket enclosures must be bonded to the grounding system, while non-metallic enclosures do not need to be bonded. The presence of other metallic components near the meter socket can also affect the bonding requirements. Any metallic components that could become energized should be bonded to the grounding system. The age of the electrical system can also affect the bonding requirements. Older electrical systems may not have been installed in accordance with current codes and regulations. In these cases, it may be necessary to upgrade the grounding and bonding system to meet current standards. The location of the electrical system can also affect the bonding requirements. Electrical systems located in damp or wet locations require special grounding and bonding precautions. The type of soil can also affect the grounding requirements. Soil that is highly resistive may require the use of additional grounding electrodes. Remember, electrical work can be dangerous. Always take precautions to protect yourself from electrical shock. If you are not comfortable working with electricity, hire a qualified electrician. Electricity is a powerful force, and it must be treated with respect. Failure to follow proper electrical safety procedures can result in serious injury or death. In conclusion, always consult the latest edition of the National Electrical Code and any applicable local codes and regulations before performing any electrical work. It is also advisable to seek the advice of a qualified electrician if you have any questions or concerns about electrical safety. Electrical safety is paramount, and ensuring proper bonding and grounding is a critical aspect of maintaining a safe electrical system. Understanding the principles of grounding and bonding, adhering to the code requirements, and following safe work practices will help to prevent electrical hazards and protect yourself and others from electrical shock.